Now we are going to derive the expression for position vector, velocity, acceleration, force and momentum for center of mass. Now first of all, what is center of mass? Center of mass is that point on the body where whole the mass of the body is considered to be concentrated. If this is a body, there is a particular point in the body where we consider that whole mass of the body is acting on this point. That point is called center of mass. See. Now we want to calculate the position vector, that is r vector, velocity, acceleration, force and momentum for this. So starting with the position vector. So first I am considering a two body system, means a system in which two particles are there. Let this be the particle 1 of mass m1, this be the particle 2 of mass m2. Let the position particle of 1 be r1 vector, second be r2 vector. Now let us consider this is a line joining this both, and this is the point where center of mass of these two lies. So the position vector r vector for the center of mass is nothing but it is m1 r1 vector plus m2 r2 vector whole divided by m1 plus m2, where m1 m2 are the masses of the body, masses of body 1 and 2, r1 r2 are their position vector, their position vectors. So now if we extend this to an interval system, means rather than 1 I have n particle, then first position vector is r1 vector, for the second it will be r2 vector, for the third it will be r3 vector, for the fourth it will be r4 vector, and for the nth it will be rn vector, so on. So in that case position vector can be written as m1 position vector for n system of particle will be written as m1 r1 vector, m2 r2 vector, m3 r3 vector, so on, mn rn vector whole divided by m1 m2 m3, so on, mn. So this is the position vector of center of mass, position vector of center of mass of n system of particles, where we have two type of system. One is discrete system, other is continuous system. Discrete means when the particles are away from each other. Continuous means when they are lying one after the other like this. It's continuous system. For the discrete and continuous system, we can write position vector as r vector for discrete can be written as summation of mi ri vector, I vary from 1 to n, summation mi I vary from 1 to n. This is the position vector for discrete system. And for the continuous system, and we know that for continuous system summation get converted to the integral, so it can be written as r vector equals to integration of r dm integration of dm. So this is r vector for the continuous system, this is for the discrete system. In component form, r vector can be written as x component can be written as m1 x1 m2 x2, so on, mn xn, in term of it's mn xn upon m1 plus m2 plus so on mn. Similarly, y can be written as m1 y1 m2 y2 so on mn yn m1 plus m2 plus so on mn. Z is equals to m1 z1 m2 z2 so on mn zn whole divided by m1 plus m2 plus m3 so on mn. So this is the component form of the position vector.